I decided to implement line following on a hoverbot with a 3 detector line sensor. This is a relic from the predecessor of the hoverbot, which was designed for a particular competition. But I am regretting it very much because it's turning out to be a very difficult concept to explain on video. But I'm going to try my best to do so. The way I approached the problem was to look at the line sensor and all the possibilities or possible combinations of sensing that can happen. So in this particular instance, we can have this line sensor detecting a line, or we can have the middle sensor detecting a line, or this sensor detecting a line, and even the line crossing two sensors. So instead of doing a lot of if-then statements to test for every possibility, I decided to do a once-off scan of the line sensor and take all those possible readings and represent them as a binary number, and use that binary number in my program directly. So the way I did it was I would scan the line sensor once and see, do we have one line, two line, or even three line? And I would say, okay, if this detects a line, I will make the binary number 001. If this detects a line, I would make the binary number 010. You see what I'm doing here. If it detects a line, it becomes a 1. If there is no line, it's a 0. And this made it possible for me to represent all the possible combinations of the line sensor in one variable with a maximum value of 7. The way I accomplished this will be discussed in a future video. But for this video, it's important for you to know that if the detector detects a line, the corresponding number is a 1. That's basically that. Now, from the binary numbers, we can convert them into decimal numbers and use the decimal number in our program directly. We can also use the binary numbers in our program, but I don't know, maybe I'm some sort of masochist, but I converted them into decimal in the program. I'm not going to go into converting binary numbers into decimal numbers because there's actually a lot of online tutorials for doing that, and I have discovered a very cool program called Numermimal, and it will take any number and convert it from that base to another base. So if I say 101 here, then it's going to tell me it's decimal 5, or if I put decimal 7 in here, it tells me it's binary 1111. So yeah, we program on a computer. We have to use a PC to program in Sin, right? So why not use Numerminal? It is interesting to know how to convert from binary to decimal, but it's really not necessary. Okay, but I'm getting off track here. Right. Now, if we look at this table, we can think, what should the robot do? If it detects the line here, then it has to move the robot onto the line. So the way I did it was to reverse this motor and make this one forward, and then it basically pushes the robot onto the line. The same conversely If it detects a line on this sensor, then it has to make this faster. No, I lie. If it detects a line on this sensor, it has to make this faster. And then this one slower in order to push the robot onto the line. There you go. And if it detects a line in the middle, boom, it basically just goes straight forward. Okay. Should it detect a line that spans two sensors, this basically means that the robot is busy to drift off the line. It is drifting towards that way. So it has to be pushed that same way in order to bring it back onto the line again. Right, so I'm not going to discuss now how I get these values. This will be for a future video. Right, let's look at how I implemented it in Great Cow Basic. I'm using an interesting command called select case. The way select case works is it looks at the value of the variable and it jumps directly to the block of code relating to that variable. So let's say line sense is 4. It won't check 6, 7, 5, no. It will go directly to 4 and implement that code. Once it has done that block of code, it will jump out of the end select and continue with our program. So you see that select case is a very convenient and short way to test for a lot of different scenarios without having to go through if then. So what I've done here, if we looked at our previous picture, if the case is 7, it means all the lines are being detected. In this case it does nothing. If case is 6, that means it is detecting on the middle of the line. So we've got our 3 sensors here and our line is going through there. Then it basically has to push the robot this way in order to stop drifting off the line. The same with all these other options. Right, turn right, turn left, forward. Those are all subroutines that I will discuss when we discuss the entire program for the line following.